On this RAM 2500HD with the 6.4HEMI, we're focusing on P0330. In plain language, this code points to a knock sensor circuit problem being seen by the PCM. The truck may turn the MIL on, and depending on when the fault shows up, it can be an intermittent electrical issue rather than something you'll catch sitting still. Broadly, think signal circuit, sensor ground, or return circuit, the knock sensor itself, and farther down the list, the PCM. Start with the basic system checks first, and if other codes are present, understand what they mean before chasing this one. Before testing, know the monitor gate. This diagnostic runs with engine speed above 2000 RPM, battery voltage between 7.5 volts and 15.8 volts, and barometric pressure above 75.2 kPa. The PCM sets the fault when the knock sensor input is above 4.8 volts or less than 0.2 volts when engine speed is above 2000 RPM. Use those conditions to help reproduce the failure, instead of guessing from a cold, static check. First, read DTCs in all electronic control units and record what you find. Save the scan report and the related recorded data. Then erase all DTCs, turn the ignition off for a minimum of 10.0 seconds, turn the ignition back on, and operate the vehicle under the same monitored and captured conditions that set the fault. Read DTCs again. If P0330 comes back, continue with circuit testing. If it does not come back, treat it as an intermittent condition, and don't force a repair that the vehicle is not currently proving out. With the ignition off, disconnect the knock sensor 1 harness connector and the PCM harness connector. Install the GPEC Diagnostic 10436 adapter at the appropriate PCM harness connector. Then measure resistance in the signal circuit between the knock sensor 1 connector and the PCM connector. The resistance should be below 3.0 ohms. Remember, the GPEC diagnostic adapter can add up to 1.5 ohms of resistance to the circuit. If the signal circuit is not below 3.0 ohms, repair the signal circuit for an open or high resistance, then verify the repair. If the signal circuit passes, stay in the same area and check the sensor ground circuit. Measure resistance between the knock sensor 1 harness connector and the GPEC adapter. This circuit also needs to be below 3.0 ohms. If it is not below 3.0 ohms, repair the sensor ground circuit for an open or high resistance, then verify the repair. If both circuit resistance checks pass, check whether the PCM can recognize the signal circuit fault. Reconnect the PCM harness connector, turn the ignition on, and read DTCs. Then turn the ignition off and install a jumper between the signal circuit and the sensor ground circuit at the knock sensor 1 harness connector. Turn the ignition back on and read DTCs again. With the connector disconnected, the sensor signal circuit high fault should show active or pending. With the jumper installed, the sensor signal circuit low fault should show active or pending. If the DTCs display that way, replace knock sensor 1 and then verify the repair. If they do not display that way, move on to the connection checks. Next, handle the connection side carefully. Perform any applicable service bulletins, then disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Inspect connector seating, connector locks, corrosion, water intrusion, weather seals if equipped, bent terminals, overheated or discolored terminals from a poor connection, push-back terminals, spread terminals, and terminal tension. Repair any conditions you find. Reconnect the PCM, inline, and component connectors, making sure they are fully seated and locked. Erase DTCs, operate or test drive the vehicle under the monitored and set conditions, and read DTCs again. If the code returns after the connector inspection and any needed connection repairs, replace and program the PCM, then verify the repair. If the code does not return, the wiring or poor connection problem has been repaired. Still verify the repair and confirm the code stays gone. The key on P0330 is to prove the circuit first, simulate the PCM's response second, and only then make the call on the sensor or PCM. For more diagnostic training, visit stepdiagnostics.com.